Hello friends, welcome to you all. And first of all, if you haven't subscribed to my channel, then please subscribe it now and also hit that bell icon. So now let's move on the video. So in this video we are going to make a recurrent neural network from scratch. So basically everything is going to be built from scratch using only the numpy library. Any of the other framework is not going to be used, and the other bigger framework like TensorFlow, PyTorch, etc. we are going to use is numpy, and for the training purpose we are going to use the binary to decimal conversion. So you can see one of my previous video on TensorFlow using LSTM. I built a binary to decimal converter. Click on the I button and you can see that video. So here the input is going to be a specific length binary number like 010110 of a specific length, and the output is going to be its respective decimal number. So that's the whole scenario. Now let's start coding. First of all, let's import the numpy. Next we are going to define a function that is going to convert the binary into integer or decimal, and we'll name it binary to int, and it will take binary number as list. So it take input like 0, 0, 1, so it should output the 1, and we are going to check it. First of all, we are going to convert it into a string. Return int binary string and 2. So this is a simple function. Let's test it. Print. Let's use Python 3. Binary to int, and like this. Let's run it. RNN .Py. Stupid idiot problems. That's the problem. So you can see we got 1. Now if I place this here, and this like 1 2 4 8, so it should be 9. You can see 9. So this verifies that this function is working correctly. So now we will build next function, which is called the dataset. So which is going to generate the input and the output for our neural network. Spelling mistake. Dataset num. Here num is the number of samples we want to generate. Like we want to generate 20 samples. So num here refers to the 20. First of all, we specify the binary length. We want to have a data of a length 8, not more than that. I think that's enough. np.zeros num and the binary. So here we have specified an empty array or matrix, not array, matrix, numpy matrix of num and binary length, and y is going to be, so numpy zeros only of num length, because it only output the one value, a decimal value. For I in range num xi is equals to np dot round, np dot random dot random binary length dot its type is going to be int. And so this xi is the binary number, so it has the random binary ones and zeros, and now its respective y is going to be binary to int xi. So that's this simple function, and it returns x and y. Now let's see this also, if it's working or not. X comma y is equals to, let's first specify the number of sample, num samples, like say 20, not 20 here, just for checking, let's say 2, and let's pair the training data, training x and training y. So this is the training data set, num samples. So now print train x and print train y. So you can see it has generated. Now we can just do one thing, we can just specify 3 so that we can manually verify if the data is correct or not. So you can see 1 and 2 3, and here 1 and 2 is only 2. So this is giving correct result. Now let's specify it again to 8 and change it to like 20. So we're gonna have our data. This is our input, set of inputs, and this is our set of outputs. So now we have our training data. Now let's generate the test data. Test x, test y is equals to data set. It's only 5. We only want to have 20 for the 20 samples for the training and 5 samples for the testing. I think that's enough. And now our main class, that is the RNN class. So this is going to the main class. Init function self. Oh, spelling mistake. Okay. Now here we are going to specify some hyper parameters. Like this is the weight. First is the input and second is the recurrent weight, or again the state of the state, which is like it takes an input and give an output, and that output is going to be act as a state and an input for the next loop in that recurrent neural network. So this is the weight. Self.W delta. Next is the W sign. Self.ETA P 1.2, self.ETA n is equal to 0.5. So these are all the parameters. The next function is the state. It's going to take the input and the state and calculate the next state. So a recurrent neural network takes two things because it works in the sequence. It's basically it differs from the feed-forward neural in the way that the feed-forward neural network doesn't make sense within the sequence of the data, but a recurrent makes sense from the sequence of the data. So a sequence matters. Like if I say A, B, C, D, E, F, G, so these all are sequence. If we just speak them backwards, so we can't speak because we have learned them by sequence. So this is just an example of like that only, a recurrent network. Here xk is the input and sk is the previous state. Xk into multiply by the weight 0 plus sk multiply by the weight 1. So I've calculated the state. Now forward state. Forward state basically means it predicting the output, what a network gives output. Zeros. 0 shape 1 plus 1 for k in range 0 comma shape 1. Next state equals to self dot state, and it takes input is k and in state k. Oh, I have to write a comma here also. That is my mistake. And s k plus 1. So the next state is going to be this next state specified above. Now we want to return this s state which contain all the states, and the last state of the last entry is going to be our output. Output gradient. Here I calculate the output gradient. We'll take two parameters here, guess and the real. So guess is the answer which is predicted by our neural network, and the real answer which is given by the training data or the testing data. Return 2 into guess minus real divided by num samples. Now the backward gradient. We take x s and the gradient output. So first, now here we'll calculate the gradient over time, because we have to, because it's recurrent network, so we have to loop back again from all those previous states and calculate the gradient and then update the weights. Another spelling mistake detected. These spelling mistakes are silly mistakes usually, and sometimes it just takes 15 minutes or 20 minutes to find one single spelling mistake, and that's horrible. And b dot zeros, x dot shape 0, comma x dot shape 1 plus 1. Now gradient over time, the last value is going to be the gradient out itself. So two variables store the value of the gradient of the weights. Now here in this loop we are going to go in reverse, because we are calculating start calculating the gradient from the backwards, from the end of the network and goes to the beginning of the network, and update all the weights. Oh, it should be k minus 1, so gradient over time k minus 1. It's okay. Now the same like this only. Grade over time k s that's correct. Now the final gradient update, k minus 1 should be equal to gradient over time k comma k should be into self.w1. So gradient over time multiplied by the recurrent weight, or you can say the weight of the state, anything you can call it, it's your own choice. Now we are going to return three things here: wx gradient and wr gradient and the gradient over time. Let me check again if there is any mistake here in the function. Gradient over time np over time x dot shape 0 and the shape 1 plus 1, gradient over time minus 1, grade 0, and I think everything is okay here. The next function is the updating using the RMS prop. and we take input output previous sign and then delta. First calculating the forward state. X is the input, gradient output is equal to self dot output gradient s minus 1 comma y. Okay, now let's print loss. Print it up to 8 decimal format. np dot main grade out. So now the weight gradients and backward gradient, and we take x state and the grade out. Now the sign should also be updated. np sign, this is w grades. So w grade is the gradient of the weights for I comma underscore in enumerate. Now if self dot w sign I is equals to previous sign, let me give a proper space, ref sign I. So if both these sign matches, then w delta I is equals to self dot eta p, else w delta I multiplied is equals to self dot eta n. So these eta p, eta n's are the two variables which are specified in the RMS back prop algorithm. Like these two value, have these two only. So these two are just, we can say, the best optimized value. You can just find it about on the Wikipedia, and this is a nice article about it, about the RMS prop algorithm. Self dot w delta is equals to w delta. It's time for the training function. TRAIN, training step. How much training step? How much iteration or training we want to give it? For step in range training steps. Self dot update our prop x y, self dot w sign, self dot w delta. Okay, and then next I comma underscore in enumerate the weights w I minus equals to w sign I into the delta. the change in weight. So this is a simple RNN. Let me run it, see if there's any error. No error, no program called, no class called. So training, just do it simply like that. Training X, train Y, and let's say 10,000. Print weights. See the change in the weight before and after the training. Let's run it once and see if it gives any error. So we have some of the most fantastic errors here. Name shape is not defined. Okay, let's check this. Line number 38. So we have an error in line number 38. Okay, so I think that's the error is that this training and testing X should, let me check. Print train X dot shape. If it gives us, so it gives us shape, that cannot be the problem. Shape is I got the problem. Line number 40, and it's this. Should be like this. Oh, some of the fantastic things. And we are getting the same loss every time. This is really fantastic. So we have some of the change in weights here. I think this doesn't make any sense. First we just do one thing, just print out the predicted answers by the neural network. So the real values, test Y, and the predicted values. Forward state, test X minus 1. Predicted answers Y. So just see what does it give us. So we have some answers near to it, like 232 is to 230, 1 is to 1.81. Let me just do one thing, just round off all these numbers so that we can ignore all these extra decimal values. So now you can see we have just, let's do one thing, come remove this one so we get answer. So now I can see 234 to 233, 37, 44. So we have data at the very near, but the thing is that our loss is just giving us not good things. So we can just see we are just near, maybe. So actually I just found a mistake here, and the mistake is that here we need to take the X for the input weight gradient, and I've taken S, so that's why it's giving us nonsense result in the loss function, and this gone. Let's just run it. So now you can see this is reduced in the loss, and now we can see that the result is fantastic, absolutely same values. You can see 120 is to 120, 180, 180. So I have just round off these values, so this is giving us some nice results. And this is the weight. Now let's see the change in the weight. If I just comment out this loss, so you can see first our loss is 1,1, loss is 1.0 something to 1.9. so you can say it's 1,2. so you can see every time it's giving us correct result. If we just increase the training data, let's remove this. If I also increase the number of size and the number of let's same only. It will take some time to train, and you can see it's giving us correct result again, and we can see there's absolutely no change in the weight. So basically that's a simple RNN recurrent neural network, and optimized using the RMS prop algorithm. So I hope you understand the concept and enjoyed the video, and you can, if you want to check this out, the source code, you can see the link of the GitHub in the description, and there are other links also in the GitHub to check out them. So thank you, have a nice day.